Hey everyone, Mr. King here. Hope you guys are all having a great night. Today we're going to be talking about physical properties and changes. And you can see on the screen it says when items change but they stay the same. So we're going to be talking about things that happen where the item changes a little bit but it's still the same item. Okay, for example, we're going to talk about like if you rip a piece of paper. It's still a piece of paper, it's just a different size or shape or something like that. So that's what we're going to be talking about today. And the great thing about this is you guys already know a lot of these physical properties because we just got done studying them as we studied the metric units. So today we're going to be talking about length, volume, mass, and we're going to add a new one that's called density. But length, volume, and mass, you guys should all be pretty familiar with and know how to measure those and find those things. So here we go. We're going to start with physical property. Okay, so a physical property is any characteristic of matter that can be observed or measured without changing the identity of the matter. So some examples of that. The length of your shoe. You could find the length of your shoe by using a meter stick. You could put that against your shoe, find the measurement in centimeters, and it'd still be your shoe. It wouldn't be anything different. That didn't change it. The mass of your science book is another physical property, finding the mass of an item. When you set it on a pan balance, it's not going to change what the item is. It's going to stay the same. The volume of a box. We've talked about a couple different ways to find the volume of an object. You can either do length times width times height, or you can do volume by immersion. And even if you were to immerse a box in water, it's still a box. It's just a wet box. So you're not really changing the identity of it. And the last one is the state of matter of an object. If you guys can picture an ice cube in your head, think about that melting. An ice cube is made of water. So even though it melts and it looks like it's something totally different, it's not. It's still water. It's just in a different state of matter. So an ice cube is water in the solid form, where ice cube melted all over your countertop is water in a liquid form. It's still the same thing. It's still water, but it's just a different state of matter. So it really hasn't changed the object. It's just changed kind of what it looks like. So a physical change is what we're talking about with the melting ice cube. Makes physical properties change, but the identity remains the same. So we just got done talking about physical properties would be like mass, length, volume, or state of matter. So if you cut a piece of paper, you change the mass of the piece of paper because part of it is missing. You change the length of the piece of paper because you've cut off part of it. You'd even change the volume because it takes up less space. But it's still a piece of paper. The identity remains the same. And some other examples, you can do the same thing melting an ice cube, as we just talked about. Washing a pair of jeans with a grass stain on it. Those jeans have a different color on them. When you get grass stain, let's say you're out playing football or you're out running around in your yard and you fall and you stain up those jeans. They're going to have a stain on them which makes your jeans a different color, but they're still the same pair of jeans. When you wash them, the grass stain is removed and it goes back to its original form of just being a pair of blue jeans. Okay, so all those changes can happen to it, and it makes them look different. There's no doubt they have a different length or volume or mass or state of matter, but they're still the same object overall. That hasn't really changed. That's what a physical change is. So if you can look at an item and say, okay, it looks a little bit different, but it's still the same thing, that's a physical change. So these are going to be a little bit of review. Length and mass, both physical properties. You can measure the length of an object. It's still the same object. Mass, which we've talked about already, and these are the things I said you guys should know already. Mass is the amount of matter in an object. And placing an object on a pan balance does not change the object. So if we set that on a scale in the classroom, all the items that you guys did in our different labs, you put those items on a pan balance and found the mass, that didn't change. It was still the same after you put it on the pan balance and after you put it on the pan balance, or took it off the pan balance. So that doesn't really change what it is, okay? So you can find the length and mass of an object without changing it. So those are both physical properties. Volume is another physical property we've already talked about, but it's something that you can change and have the object still be the same. So you can find the volume of an object without changing the object. If you measure length times width times height, that doesn't change the object. If you do volume by immersion, that doesn't change the object. It would just get wet, but it'd still be the exact same object. That's the key with what these physical properties are. They're things that you can observe without changing what the object is. So all these things that we talked about so far length, mass, and volume, you can figure all those out, and it's the same object. And that works really well for me because I teach 4 different sections of science. Whatever second hour uses, if you guys found measurements and it completely changed the object, that would be really hard because third hour would be using different objects. But because volume, mass, and length are physical properties, you guys could find all those measurements, and then third hour can find all the measurements, and then fourth hour can, and then fifth hour can. If it changed, that wouldn't work out so well. Now, this last physical property is called density. This is a new one. We did not discuss this when we talked about our metric units. Density is the amount of mass a material has for a given volume. So if you guys can picture in your mind, picture a bowling ball and a kickball. Now, they're about the same size, so they have about the same volume. Remember, volume is how much space they take up. But the bowling ball has a bunch of stuff packed inside it. That makes it really dense. Okay? They have a large amount of mass in a given space or in a given volume. Now, the kickball, on the other hand, that does not have a lot of density because there's not much mass in it. So if you ran up and kicked a kickball, it wouldn't hurt your foot because there's not much inside the kickball. There's just air. If you ran up and kicked a bowling ball, that would be a different story. That would probably break some toes. So density is the amount of mass a material has for a given volume. The way you can think of it is how much stuff is packed into a space. If you have a box that is really huge, but there's nothing inside it, it doesn't have a very high density because there's not a lot of mass inside. On the other hand, if you have a really small box, but you have a ton of little bricks inside it, that's going to have a really high density because you have a bunch of mass in one space. Now, density can change as pressure or temperature change. Imagine I took a piece of notebook paper, just a regular piece like you guys get out of a piece of notebook paper, and I dropped it on your head. It wouldn't hurt, it would float down. Now imagine I crinkled up the paper and squeezed it as tight as I could. That would be changing the pressure because I'm squeezing it and adding that pressure. Now it's into a really tight ball. Now imagine I dropped that on your head. That would hurt more. Okay, it's more density because there is more mass in a smaller space. Now, even though that little ball of paper that I dropped on your head was tiny, it was really packed full together. Okay, it's kind of like, think of a snowball. Okay, density also changes as temperature changes. Imagine I took a bucket of water and tossed it on you. That wouldn't really hurt. It would splash on you, not a big deal. Now imagine I cooled down that bucket to the point where it became ice. Ice thrown on you or dropped on you is a totally different story. That would hurt really bad. So the density would increase as I changed the temperature because the mass would increase. Now picture this. You got a bucket and it's filled with water. You fill it all the way up to the brim. Filled with just regular liquid water, and I turn it over on your head. Splash down on your head, your hair is wet, you're a little soaked, but you're fine. Now imagine I change the temperature and I freeze that water that is in that same bucket, same amount of water, but now it's ice. Even though that bucket is the exact same size, it has a different mass. Ice has a much greater mass than just water. And so as I flip it over and dump it on you, that is going to hurt a lot more because it's really packed in together. You have a bunch of mass in a really small space. So to find the density of an object, you got to do 2 things. You got to find the mass and the volume. And you guys can do both because we've done both of these in class. So let's pretend I have a wooden cube that I want to find the density of. I would first put it on a pan balance and I would find the mass. So I set it on one side. I take my gram stackers, stack them up till they balance out. I find it has a mass of 40 grams. Next, I'm going to measure length, width, and height of the cube and multiply them together. So since it's a cube, all the sides are the same. So I found each side to be 2 cubic centimeters. So 2 times 2 times 2 equals 8 cubic centimeters. Now I use the formula for density, and the formula is listed right there. You just take the mass of the item and divide it by the volume. So in other words, you're taking how much mass an item has in a given space, okay? Because that's what volume is. It's how big something is. So when I take my wooden block, it had a mass of 40 grams. I divide that by the volume of 8 cubic centimeters, and the density is 5 grams per cubic centimeter. Now here's where this comes into play. You guys have all made those little cubic centimeters in class, and I told you to hold on to those. Here's why. 5 grams per cubic centimeter means that this item, if you had one of your little cubic centimeters and set it on a scale, it would have a mass of 5 grams. Now, depending on your object, you could have a cubic centimeter that had a mass of 1 gram. You could have a cubic centimeter that has a mass of 50 grams. It just depends on how dense the object is. So the density of like an open empty box would be like 1 cubic centimeter or 1 gram per cubic centimeter. It'd be really, really light because there's not much in the box. Now, on the other hand, if you were talking about the density of a brick, where it's really packed in, if you could pull out 1 cubic centimeter of the brick and set it on the scale, it could have a mass of like 50 grams because it's really dense and really packed in. So we'll do a little bit more work in class with mass and volume, and then you guys will be able to use those measurements to find the density. So these are all physical properties that you can measure. And the key here is when you're looking at them, when you're finding those physical properties, it doesn't change what the item is. It's going to stay the same. When you have a physical change, we'll go back to physical change real quick. When you have a physical change, the properties change, but the identity remains the same. So once again, cutting a piece of paper is the best example because it's real easy for you guys. You have a piece of paper in front of you right now. Imagine you ripped it in half. It would have less mass, it would have less volume, and it would have less length. But if I ask you what it was, you'd still say, yeah, that's a piece of paper, Mr. King, because it's the same thing. So you've just changed some of the properties. All right, guys, that is all we have for today. Make sure you answer your quiz questions on the back. And also make sure you're doing a good job writing your summary. Remember, each summary point must be at least 3 words long. And also for your challenge question, it's got to have more than one answer. We want questions that get good discussions between you and your classmates. I hope you guys all have a wonderful night, and I will see you all tomorrow.